Now next condition is your resonance. Resonance, we are having one condition, that is XL is equal to XC. What is XL here? XL is the inductive reactance. Formula for the XL is omega L, and formula for the XC is 1 by omega C, right? But in this case we'll consider the resonant frequency that is different from the normal frequency. So omega L formula is how much? That is 2 pi FRL. FR means the resonant frequency, right? 1 by omega C means 2 pi FRC. So tell me, from this equation can we get the value of FR? Tell me. And after solving it, what will get the value of FR? FR is equal to 1 by 2 pi root LC. Okay, this is frequency, so its unit is ohm. You have to learn this formula. This is basically the resonant frequency, okay, in case of resonance. Next, as you know, if XL is equal to XC, can you tell me Z value is equal to how much? You know the exact formula, that is Z is equal to root of R square plus XL minus XC whole square. But if XL is equal to XC, so Z will become equal to R, yes or no? So in this condition, this is the particular in which case, in the case of resonance, right? So for this particular condition, Z is minimum or maximum? Minimum, right? Because the value is less. If impedance is minimum, then current is minimum or maximum? Maximum, right? So what we got, the another condition for the case of resonance, impedance should be minimum and current should be maximum. Okay, generally in numerical purpose, like for numerical purpose you have to remember this, because in numerical they don't give you the direct condition that resonance is there. They'll give you in the form of hint, like Z is equal to, like impedance is minimum, then we need to understood that this is the condition of resonance. If they said current is maximum, then we have to understood that this is the condition of resonance. Okay, next we need to draw a curve. We call it as resonance curve also. So for this particular curve is very important. You can mark it as important also. Okay, in this single curve we can mark it everything, like in the x-axis frequency is there, okay, and in the y-axis first we'll mark XL. As you know that what is the relationship between XL and frequency, that is XL is directly proportional to frequency, yes or no? Because XL formula is how much? XL is equal to omega L and XL is equal to 2 pi FL, right? So can we conclude that XL is directly proportional to frequency, yes or no? For directly proportional there is a graph of straight line. Remember, you have studied that V is directly proportional to I, and that Ohm's law graph is a straight line similar to that. So we have to draw XL in the y-axis, that it is the straight line, because whenever the frequency is increasing, XL is also increasing side by side in the same proportion. Okay, clear? Next, in the same graph we have to draw the condition for XC. As you know that XC is equal to 1 by omega C, and 1 by, we can consider omega as 2 pi FC, yes or no? And XC is inversely proportional to frequency. Can we consider this thing? Because we have to find out the relationship with the frequency only. Okay, and as I just told you, in the case of parallel condition we consider R minus jXC. So XC graph should be on the negative side, like this. This is the graph of XC, because XC is inversely proportional to the frequency. Okay, clear? Now next graph we need to draw it approx net reactance, or we can say total reactance. Okay, total reactance is what? If XL is greater than XC, then we can consider XL minus XC, right? If XC is greater than XL, then we can consider XC minus XL. Correct? Yes or no? So net reactance is approximately, means total reactance is approximately, we mark it like this, XL minus XC, right? So and Xc is inversely proportional to frequency, and net reactance is approximately equal to XL minus Xc. So if there is a curve shape, then we'll draw a curve shape for the Xc, and if there is a straight line, we'll draw it for the straight line. This is the graph of X is approximately equal to XL minus Xc. Okay, clear? Next, we need to draw the impedance. As you know, in the case of resonance, Z is equal to, tell me, R. It means that Z is independent of frequency, right? So whatever the value of frequency, Z value should remain same, right? Whether frequency is increasing or decreasing, but Z value is always fixed. Let us consider Z value is 5 ohm, so it will be fixed only. So we have to draw the value of Z here. So for this constant, the graph is a straight line. This is for Z. As suppose I'm imagining that Z value is 5 ohm. So at each and every point of time, Z value is same. Like if we are see, you can see that frequency is continuously increasing, but Z value is the constant, right? Clear? See the graph of net reactance. This is Xc minus XL or XL minus Xc at which whatever point it is cutting. Okay, that will be marked as resonant frequency or FR for the graph of net reactance. Okay. Now again we have to draw for current. As you know that at particular resonant frequency, current is maximum or minimum. I just told you. Current is maximum or minimum? Maximum, right? So we can draw this thing in the graph that at particular resonant frequency, current is maximum, right? Means before that current should be minimum, and after that current should be minimum. Okay, so at particular resonant frequency, current is maximum, before that it is decreasing, and after that also it is decreasing. Clear? Again we have studied one condition, that for particular resonant frequency, that impedance is minimum or maximum? Tell me. For resonance condition, impedance is minimum. So we have to draw this thing in the graph, that particular for resonance, impedance is minimum up to here, like for the Z. Before that it is higher, like it is increasing, and after that it is again increasing. So this is basically the resonance curve in a single graph only. We have to draw the XL, we have to draw XC, we have to draw X, we have to draw the graph of current and impedance. Okay, this is a very important topic. Whenever they'll say draw the resonance curve, explain resonance condition, whenever they'll ask you any question related to the theory of resonance, you have to draw this graph whether they ask you or not. Okay.